Our last section on problem solving and data analysis. So again, it's a lot of reading. All right. So a couple things as a reminder when we're talking about standard deviation and confidence intervals. These are two things that you're not going to be asked to calculate. It's too time intensive to do. You're expected to understand the effect that the data has on standard deviation and confidence interval, or how changing these values will affect our outcome. Standard deviation compares all of our data set to the mean. Okay? So we have to have an idea of what the mean is. You don't need to know what the exact mean is for most of these, or they'll tell you what it is. You won't have to calculate it for the most part. If they do, they're really easy numbers to calculate the mean. Like you most of the time just kind of look and say, oh, the mean's going to be 3. Okay? But for the most part, you're not going to have to calculate standard deviation, but you need to know the effect that it has. Okay? If your data set is really close together, a lot of your data points are clustered around your mean. You can still have some kind of outliers, but most of your data set is really compact together. That means you have a small standard deviation, a small amount of deviation. Deviation is how far away it's going. That's what deviate means. How far away are you going from the center? So a small standard deviation means there's not a big divergence from that center value. A large standard deviation means that your data is really far spread out. So those are the effects on standard deviation. Confidence interval is how confident we are in our data set or our interpretation. Okay? And the confidence interval kind of has this weird effect. All right? If you have a higher confidence interval, 90%, 95%, 99%, okay? The higher your confidence interval goes, the wider your measure of center gets to include more and more data, okay? And we'll look at an example that talks about confidence interval towards the end. But again, the lower our confidence interval is, then the narrower our data gets, okay? So we have 2 dot plots talking about quiz scores on 2 different classes, 24 students each. All right? So in our first class, there was a student that got 0, 1 that got 1, and then 3 that got 2, and then a bunch that got 3 and 4, and then a few students that got 5. Okay? Without calculating, for class A, where do we think the mean is approximately going to be? Where? Between 3 and 4. Somewhere in here, right? My mean is somewhere in that value, that range, because that's where most of my data is. I have a couple outliers, someone didn't study for their test, you have a few overachievers, okay? But most of the values are in that area, okay? So that's where my mean is located. What about for class B? It's right there in the middle. It's evenly distributed throughout the whole thing, okay? So when you're looking at class A, and we're trying to determine which of these statements is true about the standard deviation. And our options are that class A has a smaller standard deviation, class B has a smaller standard deviation, or that the standard deviation is the same. And the standard deviation is saying, for most of my data, how close is it to my mean value? The more data that is close to your mean value, the smaller your standard deviation. The more data that is spread out from your mean, the larger your standard deviation. So what do we think? Which one of these has a smaller standard deviation? A. Because most of my data points are clustered within 1.5 units from my mean, while here, my data is much more spread out. It's not all clumped together in one area. So my standard deviation here is smaller. My standard deviation here is larger. Okay? And so here we would say, okay, my standard deviation is A. Okay? My standard deviation is a measure of spread. How spread out it is. The smaller the number, the less the spread. The bigger the number, the bigger the spread. Best way I can kind of describe Okay? I didn't have to calculate mean, I didn't have to calculate standard deviation. I'm just looking at the pattern on the charts. Whew, it's a lot. Let's take it step by step. And it's a good idea that you may have to read through these answer options a couple times to figure out and eliminate ones that don't make sense. Okay? And now, let's read this first. Quality control researcher at an electronics company is testing the life of a company's batteries in a certain camera. Okay, so they're testing battery life. The researchers select 100 batteries at random from the daily output of the batteries and find the life of the battery has a mean of 342 pictures with an associated margin of error of 18. Okay? So what that means is on that particular day, those 100 batteries had an average of 342. And then to encompass the whole set, because obviously they made more than 100 batteries, they may have made 1,000 or 5,000 or 10,000 batteries. So to account for the fact that they took a very small sample, they said, okay, well, our margin of error is 18 in either direction. So that means on any given day, the mean on any given day is going to be between 324 and 360, okay, on any given day. So for that one specific set, the mean was exactly 342, but that's only for those 100 batteries. So we have to assume that there's going to be some variation among all the batteries. And so they gave themselves a margin of error of 18, okay? And so that gives us this range where the mean could be. On any given day, the mean could be between 324 and 360. Now, the thing with statistics is nothing is definite. Okay? There's nothing definite. So you have to make sure that when you're reading these, you want to kind of have that lens of, even in saying nothing definite, it's most of the time, like 99%. All right? So anything that has a really strong position of this is definitely going to happen, I would look at it with a lot of skepticism, especially when we're dealing with statistics and probability. Unless you poll every single person on the planet, you're not going to get a poll that is 100% accurate on any given subject. Unless you test every single battery that comes through that manufacturing plant, you're never going to know for sure what the true mean is. So that's why we have margin of error. So let's read all 4 of these, and then we're going to go back down the list to see which ones make the most sense. Okay? All the batteries produced by the company that day have a life between 324 and 360. All the batteries ever produced by the company have a life between 324 and 360. It is plausible that the mean life of batteries produced by the company that day is between 324 and 360. It is plausible that the mean life of all the batteries ever produced by the company is between 324 and 360. Okay? So again, have that mindset of, again, there's nothing that's definite. All right? So anything that's making a very definite statement, we want to eliminate. Okay? Do any of those make a very definite, concrete statement that we should disregard? A and B. Say, all the batteries produced. No. There's no way we could know that unless we tested every single one. We're not going to do that. All the batteries produced. No. Ain't going to happen. Okay? So now we have these. And it's plausible. Yeah, it's plausible. That's a good term with our statistics. Okay? It's plausible that we have an outcome. So that helps there. So that the mean life of batteries produced by the company is between 324 for that day, and the mean life of all batteries ever produced by the company is between 324 and 360. So we have to choose between that day and all ever. Okay? Which one is more accurate? That day. Now, is it plausible that every day the mean is going to be here? Yeah. But is it as accurate as just that day? No. So that day. Because who knows? They may change their production methods. Or, I don't know, they have faulty equipment one day. You don't know, okay? So the most appropriate conclusion based on the information that we have is that day. Now, if they did this test every day for a week or once a week for 6 months and they came up with this data, then D would be a lot more likely because now it's not just one day, it's over a span of time. And so we're pulling data from a bunch of different days and we can make a stronger conclusion about any given day. Okay? But on specifically this given day, this is the only data we have, is on one day, those 100 batteries, so we can make a plausible conclusion that on that day, all the batteries produced will be between 324 and 360, that the mean of those batteries will be between 324 and 360, okay? So take some time to read through it. But, it is what, okay? Similar concept. We're looking for definite statements and trying to pick the most appropriate solution or the most appropriate conclusion based on the information that we have. And we don't want to make any assumptions about any information that we don't have. We're not allowed to make assumptions. A community center offers a Spanish course. This year, all students in the course were offered additional audio lessons they could take at home. The students who took these audio lessons did better in the course than students who didn't take additional audio lessons. Based on these results, which of the following is an appropriate conclusion? Okay, so our first one, taking additional audio lessons will cause an improvement for any student who takes a foreign language course. Why are you shaking your head? It's very definite.
And it's talking about like
every foreign language. It's only talking about Spanish. Okay, so the definite part on this one, with this community center in Spanish, it said the students who took the lessons did better. Didn't say how much better, but they did better. So for this community center, for this Spanish course, and those audio lessons, those students did better. The reason we're not choosing A is because in nowhere are we talking about any other language besides Spanish. Okay? There's no guarantee that those language tapes will help you in Latin. Because no one knows Latin. Sorry. Latin's terrible. Alright? So we know A is out. Alright? Taking additional audio lessons will cause an improvement for any student that takes a Spanish course. So at this community center, or at the local university, or at college in Kansas, any student that takes an audio lesson home will do better in a Spanish course. Is that a valid conclusion? Why not?
Because it's talking about like...
And do we have any information on anybody else?
No, just people in that class.
Just that class. Just that community center. It's the only information we have. So this says for any student who takes a Spanish course. Well, there's a lot of people who take a Spanish course. Most of them are not at that community center. Okay? So maybe they have different resources. We don't know. We can't make assumptions. All right? For example, there's Mr. Alex, I think, is a YouTube math teacher, Professor Alex. All right? And I've heard a lot of students like his math lessons. They make sense. They're easy to follow. Okay? I'm auditing an online linear algebra course, and his video lessons are garbage. They don't help at all. So different resources are going to have a different impact. Okay? And so since we don't have any information in addition to that, we can't make that assumption. Taking additional audio courses was the cause of improvement for the students at the community center who took the Spanish course. Yeah, we can make that assumption because it's about that course, about that community center, those students only. We don't have to make any other assumptions about anyone else. Okay? Because we have enough information for that subset, but not for anything else. Okay? So we can make that assumption. Okay? I'm actually going to come back to this one. I want to do this one first, and I'm going to come back to because this is more on a similar vein. Okay? So, a polling agency recently surveyed 500 adults selected at random from a large city and asked each of those adults whether they supported a new federal policy. Okay? What was the one that just came out? Student loan forgiveness. And of those surveyed, 42% responded that they supported the new policy. Okay, so 500 adults from a large city, which has probably hundreds of thousands of people, if not millions. Okay, they were surveyed to see if they supported it, and 42% of those 500 say they would. So based on these results, which of these following statements must be true? First statement. Of all adults in the city, 42% support the new federal policy. No. We only surveyed 500. There's no way we can know for sure all. It could be 41. It could be 43. It could be 35. We don't know. Okay? There's no way that this statement has to be true. Okay? We don't have enough information. I would have to survey every single person in that city to get a definite answer. Now, if it said of all the adults in the city, the support is approximately 42%, that's more likely. But this saying it's 42%. If 500 different adults selected at random from the same city were surveyed, 42% of them would respond that they support the new federal policy. Different people, they had different opinions. It could be 41, it could be 43, it could be 45, it could be 50, it could be 35. We don't know. It's a different group of people. Depends on how the survey was gathered. Okay? How was the information gained? Maybe it's in a different district who have different opinions. It happens all the time. No way that must be true. Yeah. So this is saying of all the adults in the city, 42% support the new federal policy. That is too exact for us to know for sure. I surveyed 500 adults out of a city that probably has hundreds of thousands, if not millions of people in it. Okay? The only way I could know this for sure is if I asked every single adult. If 500 adults selected at random from a different city were surveyed, 42% of them would respond that they support the new federal policy. Different city, different people. For the same reason that we said no on 2. It's different people that have an opinion, and cities usually vastly vary in their opinions on certain things. Alright? People that live in LA are going to have different opinions from the people that live in Orlando. Okay? And then Atlanta, and New York, and Detroit. Alright? And Houston. Okay? Different geographical areas, you're going to have different opinions. So that's a none on that one. Okay? None of those must be true. Alright, now this one talks about confidence interval. Okay. So, a researcher collects information about 1,000 randomly selected physical therapists, concluded that the median hourly wage for physical therapists in the United States at the time of the study was between these two numbers. Okay? So we had that margin of error with the with the camera batteries, right? Confidence interval is the same thing. Okay, it's a margin of error. All right? So they have a median value that's between this range. All right? I'm just going to round these numbers just to make my life easier. All right? Just to illustrate this point. It would help if I rounded it appropriately. That would be good. Let's round numbers the right way. Okay? So they're saying the median is between $23 and $59. Okay, that's the median value. All right? This is a 95% confidence interval. So the median with a 95% confidence interval. All right? They are 95% sure that if they ask somebody or if they find the median value, it's going to be in that range. Okay? 95% sure that the median values will be in there. Okay? Not saying that all values are going to be in there. They are 95% sure that the median is somewhere in that range. Which, to be honest, is a pretty big range. Okay? So, they want to know, well, what if we change the confidence interval? And we wanted to reduce our confidence level. Okay? We reduced our confidence from 95 to 90. We're less confident. What effect would it have on the data? Okay? When you become less confident, your range goes down. Okay? So you're tightening those boundaries to get a more specific value, but as you do that, you become less certain of your accuracy. Okay? So let's look at what these data points do. Again, I'm going to round these numbers just to make my life easier. $17 to $65. So $17 to $65. Okay? That's one interval. Next one is $20 to $53. So 20 to 53. 20 to 53. The next one is 22 to 56. 22 to 56. And then the last one is 25 to 56. 25 to 56. Okay? So what I want you to notice is that for the second and third option, all it did with my data is shift it to the left. Yeah. All it did is shift this data to the left. 20 is less than 23, 53 is less than 59. That's not changing our confidence interval. That's shifting the data for some other method. Okay? So that's not going to be a change in our confidence interval because it didn't widen or narrow it. It moved it. The same thing with the third one. Okay? Both of those values are less than the initial maximum minimum. That just shifted it to the left. Okay? So that's not a change in our confidence interval. Our confidence interval change is either going to widen our range or it's going to narrow our range. It's going to make it wider, it's going to make it narrower. Okay? And as we go down in confidence, it's going to narrow it. As we go down in our confidence, it's going to narrow it. As we get more confident that we're including the median, it's going to make our range wider. Okay? If I say, okay, the median has to be between 17 and 95 or 65, I can be a lot more certain that the median's in there because I have a bigger range of numbers where it can be. Okay? This would be closer to like a 98 or a 99% confidence interval. Okay? 98 or 99% confident. Okay? I'm 98% sure that the median is in that value. Okay? It makes it a wider pool. While narrower, okay, well, now I have a more, a smaller range to choose from, but I'm less confident that the median is actually going to be there. All right? That was fun. Not really. I hate it. I can't wait till we do trig.
I disagree.
Do trig any day of the week. All right? Questions, comments, concerns? I mean, I know you have concerns. Not a whole lot I can do about that. Sorry. All right. Cool. That's it.